Hey everyone, welcome to another lesson of Algebra 1. We're going to be talking about Chapter 11, Lesson 5 on solving rational equations, and I like this one. This one is another straight-up algebra lesson using all the rules of fairness and equality in order to solve these equations. That makes sense to me. And we're going to go ahead and look at how to solve rational equations. Well, a rational equation is an equation that contains one or more rational expressions. Oftentimes, it's going to look like this, where you have not only fractions, but you have x's in the denominators. And this looks like a mess to solve, but I'm going to go ahead and try to show you that it's not that bad. So here we go. What is the solution of 5 over 12 minus 1 over 2x is equal to 1 over 3x. So we need to try to figure out, well, what does x equal? And because we have all of these fractions, x is equal, notice I left some space, is equal to 1 over 3x. Because we have all of these fractions, I'm going to ask you guys a really easy, a question that I know what the answer is. Wouldn't life be easier or better if we didn't have any fractions at all? Wouldn't it be nice and amazing if we can get all of these fractions in one foul swoop? Yes. All right, the answer is yes, it would be. All right. So what we're going to do is we're going to go ahead and remember, we're going to think about our dream denominator, and hopefully that will give us something that we would be able to multiply, our dream multiplier, something that we can multiply every one of these fractions by in order to get rid of our denominators. All right, so our dream denominator has to have 12 as a factor. It also has to be able to divide by 2, which 12 is fine. It has to have at least one x. All right, cool. It has to be divisible by 3, which 12 is divisible by 3. And it has to have at least one x, which is what we have. So it looks like 12x is our dream multiplier. What would happen if I multiplied every one of these terms by 12x? Well, hopefully our denominators will cross cancel. Now this is fair because, one, this is math and math is fair. And because I multiplied all three terms by the same number, all right, I'm not really changing the value, I'm just changing the way that it looks. Let's see if anything can cross cancel. Well, the 12 and the 12 cross cancel, and all I have left is x times 5, which is 5x. The 2 and the 12 become a 1 and a 6, and the x cross cancels with the x, and all I have left is negative 1 times 6, which is negative 6. And then the 3 and the 12 become a 1 and a 4. The x and the x cross cancel, and they both become 1s. So all I have left is equal to 4. And now this whole complicated looking fraction becomes something much easier to handle and something that we can actually solve quite easily using regular algebra. I would add 6 on both sides. Equals 10. It doesn't really work out as well. But then I divide both sides by 5. X equals 2. All right, I end up with an answer, x equals 2. And that would be my answer. X is equal to 2. Now, how would I check my solution? I would plug my values back in, and I would find out that 5 over 12 minus 1 over 4 is equal to 1 over 6 when I add and combine, like when I do all the stuff I'm supposed to. All right, so the good news is I'm taking a really complicated thing, I'm making it look much easier, all right, by using my rules of fairness. But this concept of finding a common denominator that works for all terms is really important. So now let's look at another example. Got it, question number 1. Let's just do example A. And what we're going to do is we're going to do the same thing. We're going to think of our dream multiplier that hopefully gives us something that would cancel all of our denominators. Now we look at our denominators, and our dream multiplier has to be divisible by 3. it has to have at least an x in there, so it has to be divisible by x. And this one has another x, so we don't have to put another one. And we're just going to go ahead and say our dream multiplier is 3x. And remember, I left some space because I know I have to multiply every one of these terms by 3x. 3x, 3x. And what can cross cancel? 3 and 3, they become 1s, and all I have left is 1 times x times 1 is x. X times x cross cancels, so I got 3 times 3 equals 9, is equal to x and x cross cancels, and this is equal to 6. So if I subtract 9 on both sides, x equals -3. Alright, so I end up getting a value of x is equal to -3. Not too bad. Now let's go ahead and look at problem 2, and I can tell you this one's going to seem a little bit more complicated, mainly because we already start with an x squared in there. And the x squared is going to complicate things. It might, well, one, I want to ask you, if we're trying to solve for x and our highest degree is 2, that means at most we might have 2 solutions, right? Because if you guys remember, the fundamental rule of algebra says that the highest degree tells you generally how many real solutions you can have. You might have, we'll talk about that later. All right, so I don't want to ruin the surprise for you what's going to happen later. All right, so let's go ahead and find our dream denominator. We're going to go ahead and look at this value. And I could say this is the same thing as 1 over 1. Doesn't really matter. It has to have at least an x in there. And our dream multiplier actually has to have 2 x's in there. All right, the highest degree is 2, so at most we have to have at least 2. So it looks like x squared is our dream multiplier. We're going to multiply everything by x squared. You get an x squared, you get an x squared, and you get an x squared. And what's going to happen when we multiply all of these together? We're going to get x squared times 1 is x squared. This x cross cancels with one of these x's, and I get -x. And this is going to equal to, well, this good news is these both cross cancel, and it equals to 12. Now, this might seem like a stretch for me to try to see if you guys remember this, but how do we solve for quadratic equations like this? How do I solve? Well, you could use an actual quadratic equation, but maybe what's better for us is if we remember the good work of our friend Shia LaBeouf, who reminds us that we have a whole system of factoring built upon this idea that if we have a GCF, then we do it. You remember that whole thing? Well, let's look at this. In order to factor this out, what we want to do is we want to move this to the other side. So we would subtract 12 on both sides, and I would get x squared minus x minus 12 is equal to 0. And this whole thing would only work if we have it set equal to 0. Now we look at the type of factoring. Is there a GCF? No. All right. Is it a special case? No. This is a regular factoring problem where we need to find factors of -12 that add to -1, the coefficient in the middle term. And I know it has something to do with 3 and 4. And in this case, I can say that +3 times -4 equals -12, and 3 minus 4 is -1. So I get this guy equals to 0. Now what are our two values of x? Our two values of x should be x is equal to -3 and x is equal to +4. Now why did the signs change? Well, because remember the zero product property says that anything times 0 equals 0. And if I say that -3 plus 3 is 0, so if x is equal to -3, then this whole thing equals to 0. You just do the opposite signs. All right. So what are the solutions? Plural. X is equal to -3 and x is equal to 4. Let's go ahead and try to solve this one. What are the solutions of this equation? And again, we're going to start doing the same thing. We're going to look at our denominators and we're going to figure out what is our dream multiplier. it has to have at least a y. Actually, it has to have at least two y's, and this has a denominator of 1, so we don't have to put anything. So we're going to multiply everything by y squared. You get a y squared, you get a y squared, and you get a y squared. And we see what cross cancels. This becomes 5y after we multiply. This cross cancel, no, this does, yeah, cross cancels here, and I end up with a 6. And this doesn't have anything to really cross cancel, so I end up with 6y squared. Fun? Fun. Now remember, we have to move this over to the other side, so we're going to subtract 5y. I'm going to get 0 is equal to negative 6y squared minus 5y plus 6. I rearranged it because I wanted to put it in standard form with the highest degree in the front going down to the lowest degree. And looking at this, it looks like we're either going to have to use one of two options. We either are going to have to use AC factoring, or we're going to have to use a quadratic formula. Quadratic formula. All right. Now the choice is up to you on how you want to solve this. Again, the world is yours, and I'll let you guys choose on how you want to solve this. Remember, the quadratic formula will guarantee work, and it might, because AC factoring doesn't always work. Now, for this reason, I chose to solve this using the quadratic formula because it'll work every single time. Now, remember, ABC is easy as negative 6, negative 5, 6. I'm just going to go ahead and plug our ABC values into x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And when I plug all of this in and I use a calculator, I find out that I get two different answers. I get x is equal to negative 3 over 2 and x is equal to 2 over 3. All right, so not that pretty, but not impossible. Now, problem 4 is called solving a rational proportion. And as soon as you see proportion, you guys should think of the butterfly method. All right, so we're going to go ahead and use the butterfly method to solve this one. Notice we can just go ahead and circle across, and we would get 3 times x plus 2 is going to equal to the product of 4 times x plus 1. And now we can distribute and get 3x plus 6 is equal to distribute 4x plus 4. And I can just move the x's on to the same side, minus 4x, get negative x, subtract 6 on both sides, and I get equals to negative 2. So if negative x is equal to negative 2, then x is equal to 2. You can divide by negative 1 on both sides, and you would get your answer. All right, how would I check my solution? I would plug them in. All right, I would get, does 4 over 2 plus 2 equal 3 over 2 plus 1? It sure does. And the very last problem that we have to kind of go over is this idea that we might have an extraneous solution. Now notice this is a proportion. So if you multiply it across, you would get 6 times x plus 5 is equal to these two multiplied together. I distribute, and when I distribute here, I actually have to FOIL out. When I FOIL out and move everything to the same side, I end up getting something that I can factor. Cool? If I factor factors of negative 15 that add to 2, I get 5 and negative 3. And I would get two solutions. Either x is equal to 3 or x is equal to negative 5. But when I plug these in, all right, notice only one of the solutions works. Now, why is that? Well, notice my highest degree, even though there's 3 different x terms, the highest degree is 1. So that's probably a tip-off that there might be an extraneous solution. On your homework, you're going to have problems where they want you to check. They're going to ask, is it one solution or no solutions or two solutions? You should always check your solutions. All right, so this one is just using pretty easy proportions. The hard part is factoring. But I believe in you guys. I know you guys can do it. And if they ask you to check your solutions, yeah, you better check your solutions because sometimes they don't always work out. Sometimes